So question 7, a number n is rounded to two decimal places, 4.76. Using inequalities, write down the error interval for n. So if we say that this is 4.76, if it was rounded, say 4.765, and this one here 4.755. So in this case, you would have had to have 4.755 is less than or equal to n, which is with n being less than 4.765. Question 8. It says the cumulative frequency graph shows information about the heights in centimeters of 60 students. And it says work out the estimate for the number of these students with a height greater than 160 centimeters. So to work out an estimate for the number of these students, you go to 160, go all the way up, and when you hit the line, you can read across. And that to me says about 48. So there are 60 students. So 60 subtract 48 gives us 12. So an estimate of 12 students. Question 9. So it says Kyle reflects triangle A in the x-axis. So he reflects it in the x-axis to get triangle B. So let's write that down. Okay, that's B. And it says he then reflects triangle B in the line y equals x to get triangle C. So y equals x is basically, if this was straight, so reflects it in the line C. So it's going to be reflected here. Okay, so you get line C, and it says Amy reflects triangle A in line y equals x to get D. So different color. If you reflect it, get line D. And then she is then going to reflect triangle D in the x-axis to get E. So this is the x-axis, and she's going to reflect it to get triangle E. So Amy says that triangle E should be in the same position as triangle C. Is Amy correct? So the answer is no. Because obviously triangle E is not in the same position as C. Says no. So she would get triangle C if she reflected D in y axis. So basically she would get triangle C if you reflected D in the y-axis. So that's the y-axis, where x equals 0. So if she reflected D along this axis, she would get C. But obviously, in this case, she's reflected D in the x-axis, which is where y equals 0, which is here. Okay, question 10. Write down the name of the planets with the greatest mass. So write down the name of the planet with the greatest mass. So it's the greatest mass here. Well, we can look through. Well, we can tell that this has the most zeros. It's got 27. So Jupiter. Find the difference between the mass of Venus and the mass of Mercury. So the mass of Venus, so it's here, 0.869 times by 10 to the 24, subtract by, here's Mercury, 3.302 times by 10 to the 23. So if we subtract these two, we can just use a calculator. We get 4.5388 times 10 to the 24 kilograms. So C, so Nishat says that Neptune is over 100 times further away from Earth than Venus is. Is Nishat right? You must show you're working out. So let's take the distance of Neptune, which is 4.35 times 10 to the power of 9, and the distance of Venus is 4.14 times 10 to the power of 7. So we can divide those numbers. We get, using a calculator, 105.0724638. So of course that means that this is greater than 100, so it is 100 times further away. Question 11. Solve this. So basically what that means is find x which works for this equation. So the first thing that we can do is that we have fractions and we want to get the LCM. So a multiple that fits in 436 as its factor is 12, so times by 12. We treat this like fractions as always. So 3x minus 2 is going to be multiplied by 3 minus 2x plus 5 is going to be multiplied by 4. And then on this side we're going to be multiplied by 2. Okay, so using our knowledge, so 3 times 3x, 9x, 3 times minus 2, so that's minus 6, so minus 4 times 2x, 8x, minus 4 times 5, minus 20, and this equals 2 minus 2x, and then at this point we just rearrange. Here we expanded. So I'm just going to take my numerical values to the other side and any of my variables to the left hand side. So this is left hand side, this is right hand side, just for me to be able to refer to it more easily. 9x minus 8x plus 2x, that's plus, that becomes negative, take that to the other side, becomes a plus, so you get 20 plus 2 plus 6, so this gives us 28. And this here gives us 3x, so that means x is 28 over 3. Can't be simplified any further. Question 12. So it says there are 30 students in Mr. Lear's class. 16 of the students are boys. 2 students from the class are chosen at random. Mr. Lear draws this probability tree diagram of this for this information. So 16 out of 30 are boys. If he picks 1, then you've got 15 out of 30 boys left. 16 out of 30 are boys, so that means 14 out of 30 are girls. And then if he picks a boy the first time, then there's still 14 girls left remaining. Whereas if he picks a girl the first time, then there's still 16 boys remaining, but 13 girls. So write down one thing that is wrong with this probability in the probability tree diagram. Well, the first thing that I notice is that when he picks a boy, okay, which means there's going to be 15 boys, he doesn't do the same thing for the denominator. He doesn't subtract 1 from the denominator, which he should do because he's already selected someone. So we can say the second student probabilities should be out of 29. So essentially the denominators should be out of 29. So it says Owen and Wasim play for the school football team. The probability that Owen will score a goal in the next match is 0.4, so it's almost half. Probability that Wasim will score a goal in the next match is 0.25, so it's a quarter. So 25%. Mr. Slater says the probability that both boys will score a goal in the next match is 0.4 plus 0.25. Is Mr. Slater right? It says give reasons for your answer. So the probability that Mr. Slater is not right, so no, and that's because the probability that they both score cannot be more than one of them scoring. So the probability of probability of both of them scoring cannot be greater than one scoring. So in essence, it's going to be 0.4 times 0.25, and that will give the probability of that both the boys will score. So both, I'm just going to put O plus W score, which is in essence 0.3. Question 13. The histogram shows information about the ages of 134 members of a sports club. 20% of the members of the sports club who are over 50 years of age are female. Work out the estimate for the number of female members who are over 50 years of age. So the way that we can do this is because it's a frequency density graph. That means that we can find the area by multiplying the height and the width. So here each square is worth 2. So we have 10 here. So here is 10. So that means 10 multiplied by, and then as you go up here, you get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's 0.5 as you go up. Sorry, that's 0.05. So that means this one here is going to be 1.1. So 1.1 times by 10 gives us 11. Here it's 10. So 10 times, and here we see again, we've got 6, 2.7, 2.8. So that's 2.8. So that's going to give us 28. And then here we've got 20. And we can see we've got here 2.1, 2.2, 2.3. So 2.3 times by 20 gives us 46. Here we've got 20 again. And then we've got on this side 1.4. So 1.4 times by 20 gives us 28. And then here we have 0.6, 0.7. And here we have, so that's 20, and then that, so this is 90. So the whole thing here is 30. So 30 times 0.7, so that gives us 21. So the question says, over 20% of members who are over 50 years old or 50 years of age are female. So years of age, so we've got this one here, so that's 50. So we know that we've got, this is half the area of this bar chart, so that's going to be 14. So over 50 is 14 plus, and then we've got 21. Add them together, that gives 35. And then 20% of 35, because there's 20% of the members, is 7, because it's going to be 0.2 times 35, which is the same as 35 divided by 5, which just gives us 7. So that means 7% of those, so that means 7 of the people over 50 are female. So here are some graphs, and in the table below, match each graph with the letters, match each equation with the letter of its graph. So y equals sine x. So let's have a look through. We'll start off chronologically and make our way. So it can't be this sine, no, it can't be sine x. This one looks like our sine x, and just something that we have to learn from memory. So you can see it's got that cyclical nature, crosses through the origin. So that for me is sine. So y equals x to the power of 3 plus 4x. Okay, so we've got a cubic, so it can't be this one. We've already eliminated that one. Can't be this one, because we're looking for one that has 2 points. So we'll look through. Okay, this one here looks about right. So F is about right to me. And then we've got y equals 2 to the power of x. So that looks like an exponential. So the more that x increases, this will be squared. So that looks about right. Can't touch, can't be equal to 0, because 2 to the power of 0 is 1. So that should be 1 there. So I'm going to go for A. And then y equals 4 over x. So it looks like a reciprocal. So if I say y equals, so at the 1, so if x equals 1, that's going to be 4. So we've already decided that one. So it can't be this, because when y equals x, so when x equals 1, we get y equals 4. So it can't be that one. It's not reciprocal, not a reciprocal. We've already selected this one. No, not reciprocal. Okay, this one looks like it's going to be our answer. So question 15. So it says A, B, C, and D are 4 points on the circumference of a circle, A, B, C, and D. And it says prove that A, B, E, and triangle D, C, E are similar. You must give reasons for each stage of your working out. Okay, so AEB, so the angle is equal to DEC, okay, because they're vertically opposite. So you can see that AEB and we've got DEC, so they're equal because they're vertically opposite. And ABE, so the angle ABE and ECD are also equal, so that's ABE is going to be equal to ECD. Yeah, maybe a different color will be better. So these are going to be equal angles because they come from the same point. So remember your circle theorem. So because they originate from the same 2 points, these are the same. So angles from same points, so subtended from same arc. Yeah, so that's just terminology. So this is the arc and they're subtended from the same points, points. So BAE, angle BAE is going to be equal also to angle BDC. So BAE is going to be equal to BDC. So essentially that's, I'm going to use the green here, so that one here. So these are the same because again they come from the same points. So again subtended from the same arc. So same reason above. And then all angles are equal, so therefore all angles equal. So ABE and DCE are similar. So again, because these points here, so A, E, and A, E, and C are a straight line, and we have to prove that A, B, E, and D, C, E. So that's this one here is the same as this one here, or similar I should say, because these angles are the same.